Picture this. It's 4 a.m., it's dark outside, and you're asleep. Then suddenly you wake up to bright flashes of light and what sound like explosions, and you see a fireball streaking across the sky. Seconds later, it's gone, and when the sun rises, you see these wispy trails floating in the sky, but can't find a crater. This happened to thousands of people in Arizona last week when a small asteroid flew into the Earth's atmosphere, and events like this are more common than you might expect. NASA officials estimate that the asteroid was around 2 meters wide and had a mass of around a few tons, and was going 64,700 kilometers per hour when it entered our atmosphere just north of Tucson, Arizona. That's more than 50 times the speed of sound in air, which explains those explosion-like sounds. They were sonic booms, like what happens when jets fly faster than the speed of sound. That speed also created a ton of compression of air, which heated the rock up until it glowed like a hot coal and broke apart into tiny pieces, releasing bright flashes of light in the sky. The smoke-like trails it left behind were actually bits of rock that were vaporized and hung around in the mid-atmosphere. And this sort of thing actually happens fairly often without us noticing. Around 80 to 100 tons of space dust burns up in Earth's atmosphere every day, while small asteroids like this one enter Earth's atmosphere maybe once or twice a month. Lots of these objects burn up over water, and they aren't dangerous even when they do fly over inhabited land. The one above Arizona, for example, probably disintegrated around 35 kilometers above the ground, around 2 or 3 times higher than most jets fly. So we don't have to worry unless they are way bigger. Like, you might remember the meteor explosion over Russia back in 2013 that was captured on a bunch of dashboard cameras and caused damage to both people and property. That asteroid was around 10 times the size of this one and released about 800 times as much energy, but these huge ones only hit our planet a couple times a century. Mostly, these are just the hazards of living on a rock that is flying through a solar system full of other, smaller rocks. Billions of years ago, a bunch of gas and dust were forming all of these rocks and other objects in our solar system, and during this time, our sun might have been able to steal an entire planet-sized object from another star. According to one new study, this might be how the proposed Planet 9, and no, we're not talking about Pluto, ended up in our distant solar system. Earlier this year, researchers at the California Institute of Technology proposed that there might be a planet orbiting the sun that no one had ever seen before. This Planet 9 could explain why some objects at the edge of the Kuiper Belt, a region of icy asteroids and dwarf planets left over from the formation of our solar system, seem to have orbits that kind of line up. The mathematical evidence for its existence has continued to grow, even though no one has actually observed this hypothetical planet yet. So if it does exist, some astronomers are wondering how this distant planet could have formed in the first place. Sure, it could have formed like the other 8 planets did and was somehow pushed to the outskirts of our solar system, but a study published in April this year has an exciting alternate explanation. Our sun might have stolen Planet 9 from another star. When our solar system was forming around 4.5 billion years ago, the sun was in a stellar nursery, a big cloud of gas and dust that can form tens or even hundreds of stars. So our infant sun probably had some close neighbors. And these computer models suggest that the sun could have plucked a planet from the outer reaches of one of those other fledgling solar systems. If the two systems got close enough together and the planet's orbit was just right, it could have passed smoothly from its home star to our sun, ending up with an orbit like the one that scientists think Planet 9 has. Even though it was billions of years ago, this interaction should have also affected the orbits of some of the other objects in the Kuiper Belt. And that's something that scientists can study while we're still searching for evidence of Planet 9. If this really is how Planet 9 joined our ranks, then it presents a golden opportunity to study an exoplanet, one born around another sun, without leaving the comfort of our own solar system. So fingers crossed for Planet 9. Let's find it. Thank you for watching this episode of SciShow Space News, and especially thank you to all of our patrons on Patreon who make this show possible. If you want to be one of those people and help us keep making episodes like this, you can go to patreon.com/SciShow, and don't forget to go to youtube.com/SciShowSpace and subscribe.
How did water get here in the first place? Where did the cycle begin? Let's just say it might be out of this world. First, let's start with the components.